In this video, we'll start discussing the simplification of rational expressions. To begin with, we must define a rational expression as anything that can be written as a fraction. To evaluate an expression, it's really quite simple. You plug numbers in, and you see what you get. If you have x plus 2 over y minus 3, you'll be told x is 5 and y is 4, and you'll plug 5 in for x, 4 in for y. And you just work it. That's all you do. Evaluating expressions, you've done that many times already. But what you may not have talked about is you need to make sure that your expression is not undefined. And by that we mean you can never have a 0 in the denominator. That doesn't mean that the variable in the denominator can't be 0. It means the total of the denominator cannot be 0. So, if you are dealing with an expression, let's say you've got x plus 5 over y minus 3. If you were to evaluate it, they say x is 1 and y is 2. You would plug in 1 plus 5 and 2 minus 3. You would get 6 over 1 and just have 6. That's the evaluation part that I was talking about. And I'm sure you recognize that you've done that many times. The other part, dealing with making sure there's never a 0 in the denominator. So let's consider you have the rational expression 4 over x minus 3. We want to make sure that there's never the total of a 0 in the denominator. So to find that out, we create our own mini equation over on the side here where the denominator is 0, and we find when does that happen. Well, that happens when x is 3. So if the question is what is the domain of this rational expression, usually we only really deal with this when we're talking about function notation. So we're saying, in fact, what is the domain of this function? The domain will be any number x such that x does not equal 3. We can use any number we want for x, but we cannot use 3 because 3 will put a 0 in the denominator. And a lot of times you'll just see it written, f at x equals 4 over x minus 3, comma, x does not equal 3. So that's what they're saying. We can use any number we want as long as x is not 3, because 3 would put a 0 in the denominator, and we can't have that. That's undefined. Now, the actual simplification of rational expressions is really easy. You factor the numerator, you factor the denominator, and you cancel out common factors. And I say factors because a lot of times, in fact, more often than not, the error made here is when people factor things that are not factors. They have to be factors, and we need to remember that factors are things that are being multiplied together. So if it's not being multiplied, if it's being added or subtracted, then that's not a factor. Let's take a look at that. Let's say we have the rational expression of x squared minus 4 over x squared plus 4x plus 4. Our procedure is to factor down the numerator. So if we factor the numerator, we'll get x plus 2 times x minus 2. The difference of squares there. Then our procedure says to factor the denominator. Well, that's going to give us an x plus 2 and an x plus 2 because it's the factors of 4 that add to be 4 are 2 and 2. Then our procedure is to cancel common factors. The x plus 2 as a quantity here is a factor being multiplied by the quantity x minus 2. Same thing's happening in the denominator. We have a quantity multiplied by a quantity. So since those quantities are being multiplied, those quantities as a complete unit are factors that we can cancel. So we can cancel out the x plus 2 and x plus 2 because those are common factors, and we'll be left with x minus 2 over x plus 2. And here's where errors rise, because people look at this and they'll say, hey, there's a common x and a common x. But those x's are not factors. They're not being multiplied by anything at all. We cannot cancel those. One way that I look at it is those plus and minus signs are stronger than steel. They are holding on to those terms on the sides of them. That x and the 2. That x and that 2. They are holding on to those tight, and they will not let go of anything. Right? Same thing was happening up here. That plus sign was not letting go of that x or 2. But we didn't need it to let go of them. We just got rid of them completely. The entire thing. So they all went together, right? They went down with the ship. They, whatever terminology you want to use for it. They all went at the same time. But once you have those plus minus signs, they either all go or none of them go. You cannot break it up. They will not let go of anything. It has to be just common factors, not common elements, common factors. So that's all we can have then. That would be our answer. X minus 2 over x plus 2. That's as far as you can go. That's simplifying rational expressions. Now to continue on, let's look at multiplying and dividing rational expressions. If you'll recall, the process of simplifying a rational expression was to factor the numerator, factor the denominator, and cancel out common factors. Factors. Now let's look at the procedure for multiplying rational expressions. Look at that. It's almost identical. What's the difference? Instead of just factor the numerator, it's factor the numerators, plural. Factor the denominators, plural. And then cancel out common factors. And what that looks like then is, let's say we've got x squared minus 4 over x squared plus 4x plus 4 times x squared minus x minus 6 over x squared minus 9. All right, our procedure says to factor the numerators. So I go ahead and I just do that right above the numerator. So I have x minus 2 times x plus 2 for this difference of squares up here. And then I've got the factors of 6 that subtract to be 1 are going to be 3 and 2. The larger one gets the same as the b, the other's opposite, so they subtract. So I've factored the numerators. The x squared minus 4 and the x squared minus x minus 6 don't exist anymore. I factored them. They're now their factors. So then the procedure says factor the denominator. So I'm going to do the same thing down here. I'm going to have x plus 2 and x plus 2. The factors of 4 that add to be 4 are 2 and 2, and everything's being added. So everything's the same sign. And then the difference of squares here will give me x minus 3 and x plus 3. And I always cross out what I've factored, so I don't need to look at that anymore. I'm done with that. Now all I have is a bunch of factors. And our next procedure says to cancel out any common factor. And it doesn't matter, we can see the obvious here. We've got the x plus 2 and the x plus 2. We've got the x minus 3 and the x minus 3. That's normal. You've done that. But here's the new part with the multiplication. So far that's just simplifying rational expressions. The multiplication part comes when I do the x plus 2 and the x plus 2. As long as I'm going numerator to denominator, it doesn't matter what fraction the factor is in. Because ultimately, multiplication means just multiply everything straight across here and everything straight across here. So all the factors from here will get joined up with all the factors from there. So it's really just one giant numerator and one giant denominator. So it doesn't matter if it's coming from one fraction or another fraction, as long as it's just numerator to denominator. Anything that's common, any common factor, can be canceled out and leave you with your answer here of whatever's left over. I've got an x minus 2 left up there in the numerator, and I've got an x plus 3 left down here in the denominator. So that would be my answer, x minus 2 over x plus 3. So if we take another look at our process here, factor the numerators, factor the denominators, cancel out common factors. Alrighty, and the last part of our video here will deal with dividing rational expressions. And usually I reveal one line at a time here on this slide. It's an extremely complicated procedure. Pay very close attention. Alright, first we start by multiplying the reciprocal. And then, well, that's it. That's, you know, I like to build up the fear and the anticipation. Oh, this is going to be hard. No, it's not. It's just multiply by the reciprocal. That's it. Let's look at that. Let's say we have, we'll put an a term in this one. We'll have 4x squared minus 9 over 2x squared minus 4x plus 3 divided by 4x squared plus 12x plus 9 over 6x cubed plus 3x squared minus 3x. Okay, let's look at our procedure. For the dividing of rational expressions, our only procedure is multiply by the reciprocal. So that's going to give us 4x squared minus 9 over 2x squared minus 4x plus 3, exactly what we had before. But now it's going to be times the reciprocal, giving us 6x cubed plus 3x squared minus 3x over 4x squared plus 12x plus 9. Now what do we have? Now we have a multiplication of rational expressions. It's no longer a division problem. So now we go to our process for multiplication of rational expressions, which says to factor the numerators. So that's going to give us 2x minus 3 times 2x plus 3 for that difference of squares there. And then we're going to factor out the common 3x. And by the way, I made a professor alteration here. I changed the 3 to a 9 because otherwise this wasn't going to work out just right. I had a slight error in my head putting all this together. So 3 became a 9, and now we can continue from there. We factor out the common 3x, we get 2x squared plus x minus 3, and then we factor that further, and we have the factors of 6 that subtract to be 1 are 3 and 2, so we have 2x plus 3, 2x minus 2, and we throw out the common here so that it becomes x minus 1. So that's our numerator totally factored. Now in our denominator, another professor correction, the 4's have become 5's. Now this will work. We want the factors of 6 that add to be 5, that's going to be 2 and 3. The larger one gets the same sign as the b, the other one gets the same so they can subtract, so they can add, and then we throw out the common. So that's done. And then for the other denominator, we factor that down, and you might recognize that as a perfect square trinomial, so it's going to factor into 2x plus 3 quantity squared. So we've factored out our numerator, we factor out our denominator, and now we cancel out anything common. Common factors, factors, factors. So looking at the first factor here, hey, we have a common 2x minus 3 and 2x minus 3. On the other fraction, we have a common 2x plus 3, and in the denominator, since the exponent 2 is saying, hey, I have 2 of those, I can just cross out that exponent. So now I only have 1 of them. That's kind of a shorthand for canceling, and it's perfectly reasonable, perfectly legal. But we have to continue canceling because we have a common factor 2x minus plus 3 and 2x plus 3 going like that, and we have the common x minus 1 and x minus 1. So what are we left with? Everything's canceled out except that 3x, and that a lot of time is overlooked because people get so used to looking for quantities that they ignore or forget to notice that there's variables or numbers that have been factored out. So our answer would just be then 3x, because anything over 1 is just itself. That's multiplying and dividing rational expressions. Quick, simple, painless. I think you should be doing just fine at that.